Software Perspectives with Richard Campbell.
The Azure DevOps podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Hello, welcome back. I'm your host, Jeffrey Palermo, and you can go to www.azuredevops.show to see past episodes and show notes. And if you are running a community user group or conference, or even speaking at one, I'd love to support you with a couple of giveaways, giveaway copies of my new book, .NET DevOps for Azure. And you can find the book at bit.ly/.NET DevOps book. That's bit.ly/.NET DevOps book spelled out, or the ebook at bit.ly/.NET DevOps ebook. My goal through the book and this podcast and other initiatives is to simplify that complex world of software development on the Microsoft platform and for people shipping software. So I believe that really every developer and every development team can be world-class when empowered with the right environment, the right tools, and the right process. And now let's get on to the show. My guest today is Richard Campbell. Richard wrote his first line of code in 1977. His career has spanned the computing industry, both on the hardware and software sides, development and operations. He was a co-founder of Strange Loop Networks, acquired by Radware in 2013, and was on the board of directors of Telerik, which was acquired by Progress Software in 2014. And today he's a consultant and advisor to a number of successful technology firms and is the founder and chairman of Humanitarian Toolbox at www.htbox.org. It's a public charity that builds open source software for disaster relief. And Richard is also the host of two podcasts, .NET Rocks, www.netrocks.com, DOTNETROCKS, as they say on the podcast. It's the internet audio talk show for .NET developers. Also, Run As Radio, www.runasradio.com. And that's a weekly show for IT professionals. Richard, how are you, sir? Welcome.
I'm confused, I'm sitting in the wrong seat.
Absolutely. You're usually the host, and you're usually asking other guests questions.
Oh, for sure. 2, 3, 4 times a week is kind of the norm for me. But now, sometimes I get to sit in the other seat once in a while. I would not be hypocritical enough to not come on shows when invited. After all, I invite a lot of people to come on my shows.
That's an understatement. So you're always asking the questions, and yeah. I thought, you've had a really long and storied career in the software world, and you've got a story to tell, and you've done so many interesting things, but you're always helping other people to tell their stories. So I thought, man, I need to get Richard on the show.
Appreciate that. Well, in the podcast alone, you can realize I spend time in the dev world and in the ops world. Like, where do I do my DevOps show? It's like, well, it's on both, because there's very much an operations-centric aspect to DevOps, and there's a development-centric aspect to DevOps. And you see it emerge in either part of an organization, hopefully at the same time, but rarely.
Now, you confess you wrote your first line of code in 1977. In that era, was there a division between dev and ops at all?
Yeah, there was, but not in the microcomputer realm. In the bigger iron, you had your professionals that operated the machines that were separate from the programmers, even more so, I think, than today. But the early days of microcomputers, of course, you did everything. This is before networking. This is certainly before the internet. So each machine was sort of a standalone beast, and you wrote code onto it. And you sneaker netted software from one machine to another. So you were pretty tightly integrated then because there just was no room for multiple people in a lot of respects.
Right.
It wasn't until networking came to pass. Well, the hard drive helped too. I mean, in 1977, that was a TRS-80, and it had a cassette tape player for storing software. There's only 4K, so you could almost type the program in if you wanted to.
Yeah. I was pretty young in that era, but I saw some of
Well,
those.
so was I. I was only 10 when I started programming.
Oh, you were 10. Shoot. I didn't program until I was 14.
There you go.
All right.
And just hung out in the Radio Shack because it was the only way to get machine time was to actually sit in there. And the salespeople didn't mind because as long as a 10-year-old could program the computer, you could sell it to a 30-year-old.
Right. So there's so much talk about DevOps, and just like with the Agile movement, there's a whole lot of buzzwords. And so I think let's attempt to not be buzzwordy and just talk about shipping software and what that takes and what you've learned over your time doing it.
Well, yeah, we shipped software before they came up with the word DevOps, and it wasn't all horrible either. I really came into my own during the .com boom in the late 90s, early aughts. Because we needed high performance websites, and I have strong experience in the hardware and software side. And so I became a performance tuner mostly. You only have so many hours you can work. And the best paying work I could find was that diagnostic work of figuring out why isn't the website going fast? Like, why is it struggling? Because that can happen anywhere. That could be networking problems, that could be database problems. People blame the database a lot. That could be software design. There's so many places where a website becomes slow, and actually being able to diagnose that and then figure out how to free it up, find the choke point in the app as it stands and expand that choke point. So now there's a new choke point until you're finally fast enough that the customer's happy. And that was naturally cross-cutting across teams. That was just the job. You had to talk to devs, and you had to talk to ops, and you had to talk to the DBAs, and you were on the phone with the ISP and dealing with the data centers. Like that was the job. And so I don't think I ever thought anything of the fact that you wanted an overall view of how software was built, deployed, and operated. And any place that I found during that era that was thriving, that had a great site, that was singing and dancing, we called them high-functioning teams. And what was the hallmark of it was I'd walk into the meeting room that had operations folks and developers and networking folks, and they were teasing each other. They were joking. They were all on the same side of the problem. The challenge here is keeping the site running well. And they weren't each other's enemy. They were each other's asset. Now, and I've seen the opposite. I mean, the great thing about being a consultant is being able to walk into a lot of those rooms. And I've also walked in the room where dev's sitting on one side of the table and ops is sitting on the other side of the table, and they're arguing whose fault it is.
Yeah.
They agree that neither has enough data to convict the other, and they're going to have to reschedule this meeting for the next week. And then 15 minutes before the meeting next week, they try and dig up enough evidence to blame the other guy. Repeat infinitum. As soon as the other members of the team are actually the enemy, you're lost. And this has got nothing to do with technology. This is everything to do with people.
Yeah. Yeah. That's a good point. Regardless of what era it's in, even long ago or just yesterday, that's a people problem.
You still see it today. You still see a dev team that they're automated the way they hurl their software to operations and then go off and have a party because they quote unquote shipped, but they're still doing that same essential mistake, which is we don't celebrate until everybody gets to celebrate.
Right.
I've always meant to write the DevOps books that's entitled "When to Throw the Party."
You should write a book. You've got a book in you.
I'm working on the book on the history of .NET, which is all consuming, and I'm enjoying the heck out of it. But it's just sort of an axiom of I don't celebrate at the expense of others. So you check the software in, and it doesn't immediately die. The thing builds. you can't celebrate yet because they still have to deploy it, or if nothing else, is going through some kind of QA process, hopefully. And when it passes that, you're still not ready to party.
Right.
When it gets deployed, is that time for a party? My favorite mechanism, and this is even before the .com boom, I got into the habit, because I've been burned by it, of I would read the logs of a deployed app in detail for about 2 weeks after we shipped. And this is back when we were shipping twice a year. So for a couple of weeks after we ship a new feature, I would watch the logs to see if the feature was being used. And more importantly, was it getting close to taking the system down? How often have we seen a crashed application? And when you go back through the logs, you can see the app's been telling you for a month that it's getting closer and closer to dying.
Yeah.
And so, but watching those logs, I was able to write these status reports. It's like, hey, 2 weeks ago, we deployed this new reporting engine. Here's how many people are using it. These are the reports that are being run. Like, to actually tell everyone, we pushed out a piece of software, and whether you're using it or not, others are using it, and it's been beneficial. Plus, I had a gauge that it was healthy. And that, to me, was the right time to throw a party. Mm-hmm. When the customer was using the software and it benefited them, well, there's your full value chain, right? From idea, creation, development, testing, deployment, utilization. You get to that point, now you have something to celebrate.
Something that seemed maybe a phenomenon of just recent years. There's so many new entrants into the software world and so many new companies building custom software with just a really small development team. You mentioned you watch the logs. And I just thought to myself, okay, where is the guide to teach developers how to structure logs and what to log?
Well, there's no substitute for asking a developer, how well is your new feature working in the field? Because answering that question is a logging, reporting, dashboarding problem. One of the things we did do at Strangely that I found hugely useful was that every developer did a quarter with the integration engineers. We were making an appliance for making websites go faster, which I don't know if I'd even try and do that today. That meant putting a piece of hardware into other people's networks. And our system integrators, our SIs, they had the hardest job in the company by far, because every single network you touch is different.
Yeah.
And it's broken in some respect. My experience working with the SIs at Strange Loop was there was not an install where they didn't discover something happening in the network that the customer didn't know about. I'll give you an example. You'll laugh like crazy on this one. So we're an appliance for reading web pages as they're coming and going in and out of the web server and figuring out how to optimize them. And so if you're using SSL, you're encrypted, we can't read them, right? No way to make it work. So either we're your SSL endpoint or you have an external SSL endpoint.
Right.
And here's a customer that had bought an F5 big IP. In fact, they'd bought two of them. These were like $60,000 a piece.
Yeah. Big time.
And they are arguably, even to this day, the best SSL endpoint in the world. Hugely performant, incredibly powerful. And the guys who know how to set them up are magical. In fact, and this company was no different. They had been convinced that this was the right device. They had it installed. People in white lab coats had come and configured it for them. They had no skills internally on how to operate that device, but it had all been set up by the pros, and it was done, and it was awesome. And so we were like, oh, great. So that means it'll already be decrypted by the big IP device. We'll sit behind that. We can read the packets. We're good. The SI goes, sets up the box, can't read any of the packets.
It's not being decrypted.
It's still encrypted. It was being decrypted by the web server still.
Wow.
For a year. So the big thing that happened was we put devs with the SIs. Every dev would do a quarter with an SI. And they would come back thinking differently about software. How do I tell this SI what's going on, right? The person in closest contact with the customer, the person that's trying to actually make it work, how do I give them insight that it's doing the right thing? It changed the way we built features, was to put devs in the field where they had to live with the software. They were happy to come home after the 3 months, but they were enlightened.
Right.
And I've now realized years later, the best thing you can do when you're trying to work across teams, I mean, we talk about this in DevOps today all the time now. This, development's living in their island, operation living in their island, QA could easily live in an island, DBA's living in their island. The biggest concern I have is that everybody thinks that everybody else's job is easy. And so anytime I can mix those teams together, my actual goal is for them to walk out of the room at the end of the day or the end of the hour going, wow, dude, your job's tough. Right? That insight that we're all working hard, all on different things. We have a different set of priorities because we have different responsibilities, but that the ultimate goal of delivering value to the customer is common. And it's the thing we have in common across the board. And if any of us isn't working well, we're impairing that, but that everybody's job is hard. That's the insight. Is like, if you can get to that point where you respect the skills of the people who do the other jobs, then all of a sudden we're all on the same side of the problem.
Right. And a greater perspective. And one of the things that I noticed today is there's so many people talking about development and being a developer, and then there's these other, I guess they used to be much bigger than they seem to be today, and they still are in enterprises, like you mentioned, QA and security groups, and a lot of things are starting to become integrated. But then I look around and say, okay, there's a lot of developers, but where are the architects? Now, the enterprises have architects and whatnot, and it requires a great deal of perspective and experience. You are a software architect. You have acquired all of those skills, and so what in your mind? I asked multiple people this: how does a developer become an architect, and what the heck is an architect?
Well, let's also recognize that even if you're a one-man band building and deploying software, the architect's role, the development role, the QA role, the operations role, the DBA role, they're all still there. You're just doing them.
Right.
And, I would argue that don't do too many at the same time. Like, try and consciously switch hats and know what role you're in. And obviously, you're going to be stronger or weaker in each of those roles, and you're going to give more or less time to each of those roles too. And when you're in conflict with yourself, that's part of the challenge. The dynamic between architecture and development is very interesting because architecture works towards ideals. How do I build sustainable, maintainable, change-tolerant software? Where a developer's ideal is, how do I get this feature done in the least amount of time possible with sufficient quality that I won't be killed? And that conflict is a super useful conflict, right? That you push back on the architect to say, hey, I get that you want this broad design, but this is going to take forever to code, or the features don't work that way. The app doesn't build that way. And you push back. Nobody's perfect. A good architect stays involved in the process and potentially even modifies the architecture when they run up against the limits of the platform at the time. But I would argue that it's very challenging for a developer to conflict with themselves. One or the other is going to suffer. And I suspect because code is the most real thing you can do, that you're going to defer to coding over architecture almost every time.
Yeah.
So you can learn about architecture, but the ability to actually conflict with yourself, that's a really hard one. It's one of the reasons I think that architecture as a role is typically outsourced or contracted. But it's not a one-time thing. You don't hire a guy to do architecture for your application and they drop a document on your desk and you never hear from them again. I would hope that architect, not any different from an architect building a structure, stays involved in the initial iteration at least, to make sure that that you're following the ideals that existed in the architecture, and that the architecture was validated by the code that it was built with. But I think each time you see a situation where people are trying to do both jobs at the same time, the architecture suffers inevitably.
Yeah.
The Azure DevOps podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Now, over, I guess, the first 10 years of the new millennium, there were these really, really large, I guess it's not isolated to that, really large monolithic systems. We started calling them the monolith, and people are breaking them up today. And now there's the buzzwords of microservices and all that. How, just out of curiosity on the buzzword front, how would you classify microservices? Because so many people I talk to say, I hear about all this thing and it's what everybody's doing, but I've never seen one out in the wild.
Well, and because how many times do you get to actually greenfield with a new architecture? It's virtually never. So, I mean, my mind, what happened in SOA, if you want to go back to the previous
that was early 2000s, right?
Yeah. So if you go back to that sort of monolithic set of services, was we created a consistent set of boundaries. Like there was one boundary around everything. They all had easy calling within each other. So, we got some efficiencies there. We took a bunch of assumptions that being one thing solved, and eventually you run into situations where different parts of the app need to scale differently. Different parts of the app need to be modified more often, and it disrupts too much of the app. And so the decomposition, which ultimately what microservices is breaking apart of the application, was really an acknowledgement that different pieces could possibly be coded in different ways. Like suddenly functional languages between F# and Haskell and the likes have shown strength for certain aspects of an application where it makes sense to let's peel that piece and write it in this new form because it performs so well or scales so well. And so I've never seen a pure microservices implementation. What I've seen is a monolith that's had shavings taken off of it, pieces pulled out of it and re-engineered, living in separate security contexts, in separate transactional contexts, potentially written in different languages, and scaled and updated independently. And so, what do you do but study your monolith and say, where is the problem child? Let's go get the problem child and put him in his own can. Like pull him out, re-engineer him in a way that's going to deal with that problem, whatever that may be. And the monolith still calls to it and from it, but it's living by itself. There's your microservice.
Yeah. One of the challenges with an independently running application or service is the state, the data. Rather than the compute. And there always seems to be a challenge when breaking things apart, saying, okay, what state does it really own, and what state does it merely ask somebody else for?
Right, or it gets passed along to it, right? It's sort of a bi-val transfer of information consistently, right? Essentially a deterministic data versus a non-deterministic data.
Right.
And again, one of the reasons we ended up in that monolith is it made state management super easy. It's all in the same can. It's all in the same context. So all state available to all things. But it's also a security vulnerability, right? It means if you crack one service, you crack them all.
That's true.
So, there's a strength to pulling these things apart. But you're paying overhead. The more times you're fetching state, whatever that may be, the longer it's going to take. Mm-hmm. But it also say that large scaling systems, and this is going back to my experiences building the early websites during the .com boom, the goal is not to have one request be the fastest possible request. The goal is to have a consistent request speed no matter how many requests you get. And so I'm willing to sacrifice some single transaction performance to get consistent performance over the volume we're actually serving. As soon as I see a dev validating a feature by being the only person running it, it's like, it's not a valid test, dude. That's not how it's going to work. Right? Build the script that actually tests it at scale, and you'll find out that as the number of users rise above, say, 1, you have performance problems.
Right. Well, even batch jobs that run in the middle of the night, when you're in the days of timing it, so, okay, this one's going to run at 2 a.m., then that should be done by 3 a.m. And performance tuning is a skill, because if something takes an hour to run, well, shoot, and after tuning, you may get it down to 2 minutes, and like, man, that was wasteful.
Yeah. Well, and also, why are we doing these things in synchrony?
Yeah.
Right? Like, as soon as I start seeing people thinking in terms of this, then this, and this, and this, is like, where is the actual dependency?
Right.
What of these things can run asynchronously and can run in parallel, which not the same things, but, need to be done together. That's the way we need to think when we want to tolerate the fact that our data sets are going to keep growing, that the number of customers are going to keep going up, and that we want to keep serving them well. The fact that it works well today is simply not enough. I suspect the company has goals, and they're more than what we have today.
Mm-hmm. There's these rules of thumb that might have popped up just over, at least certainly over my career, where you mentioned the batch jobs that have to run synchronously because they have these temporal dependencies. Converting those to queue-based systems where individual messages trigger other that seems to be a general yes. Convert batch job architectures to queue-based architectures.
And asynchronous architectures wherever possible, right? More pub-sub behaviors. Like, all of those things speak to us thinking about new workflows. But, we talk about in DevOps that there's this, as our practice starts to grow within an organization, we sort of walk through the actual workflow of an application, how things get built, how they get operated, how reporting happens. And you discover these little enclaves, these old parts of that's just the way we've done it sort of things, where that might be all IT or ops knew how to do. But as soon as a dev looks at it, it's like, dude, I can re-engineer this with this tool, and like all of the stuff will just be automated and it'll happen simultaneously, and you won't have to take care of it anymore. Like, that's the power of a good DevOps practice, is when the different teams each bring their different skills to the sets of problems. They're able to show each other their challenges. They see them differently. They will fix them differently. We each have our own tool. You're a dev, you kind of got the dev hammer, and the ops has got the ops screwdriver, right? And they've each trying to make everything a screw and everything a nail. They actually sit together. It's like, this is better served by the screw. I'm like, okay, let's do it a different way.
Mm-hmm. Right. Now, you were on the board of directors of Telerik before it got acquired by Progress Software.
Yes.
And that business model with developer tools and components, thinking about application types. I know that now at this point, it was 5 years ago when the acquisition happened, but that's a constant question for people to ask, okay, what user interface types and what application types are going to be the next trend, the wave of the future? What should I invest my skills in? Because there's some that don't go anywhere. There's some that have a good run and then die off. And then there's some that have a long run. Like, if you learned SQL long ago, you're still using it today.
Sure.
But that's not true with everything.
Although, that's got its own hangups too, because we're storing data in lots of different ways today.
Yep.
Not just in relational databases. And so I would hope that anybody who had strong SQL skills also sees themselves as a steward of data and is responsible for wherever data lands in an organization.
Yeah. So in 2014, SPA applications coming up, the JavaScript renaissance, but now where you sit, where do you see the future? If a developer, the small shop, the 1, 2, 3 developer shops where they have to pick, and what would be your best pick on their Microsoft platform, Visual Studio developer, for all of the UI and application types available today?
Well, you can't go far wrong with the JavaScript stack these days, if you're modern about it, because you do have the Electrons of the world for cross-platform deployment on a client if you want. The progressive web app opens huge doors for the capabilities in browser execution, including on the phone. Like, there is interesting motion there all around. But at the same time, with WebAssembly, we've now cracked open this idea of where JavaScript used to be the only language that would run absolutely everywhere. Now C#'s running everywhere.
Yeah.
So, part of this is, well, what language do you love and how do you think about how you code? Folks that are comfortable in the dynamic world where they like being able to throw things together quickly and build test harnesses around validating it, the dynamic typing of JavaScript works just fine, right? And if you prefer more static typing, you go through it down the TypeScript path for more sustainability. But C#'s got its strength. It's in the midst of this renaissance. I should know. I'm literally writing the book. And you're starting to see it appear in a lot of different locations. And it's interesting to see companies like Telerik in progress in the modern era that are jumping on the Blazor bandwagon because we are seeing mainstream developers looking at this seriously and going, there's a client approach where I could actually share validation code as an assembly, both on the server and on the client, all written in C#.
So that premise, you wouldn't have to choose, okay, WinForms here, WPF there, Xamarin there, Web there. You really would be able to have potentially one set of screens even, maybe a little bit different formats, but that could run everywhere.
But it could. Now, it's going to be challenged when you go into mobile because it's a bit beefy, right? That's a lot of code, right? But we're dealing with frameworks and stuff on the mobile side anyway. Like, there are no perfect mobile solutions, Jeff. Every one of them has sins it's covering up. It doesn't matter what you're programming in, one way or the other. You're either going all native and you're spending on multiple teams and pain and angering customers because feature deployment is asymmetrical between iOS and Android, or you're trying to build the master project the sort of Xamarin way, and you're making compromises in your UI and dealing with that abstraction, or you're coding in JavaScript and cross-deploying that way, and you have a bigger footprint, and you're dealing with the overheads and differences in behaviors between those builds, or you're playing with C#, the initial Blazor deploys, and you're figuring out load times are too high, and the thing's too big, and not all phones run the same. Like, nothing's free, man. There's no easy answers. It's all work. The challenge is, do you know your tools? Can you pick your poison?
Yeah. Language seems to be just a strategic decision, because if you've already gone super deep in JavaScript and you know it like the back of your hand, then hey, make that investment pay off. But if you spent over a decade with C#, that could be compelling. Make that investment.
But in both cases, the languages suffer the same problem, which is that they have evolved rapidly, and I'm questioning whether you've evolved with them. If you're not using the new features, if you're still I meet folks that are writing C# the same way they did in 2010 with C4.
Yeah.
And which means they don't have 10 years of experience with C#. They have 1 year they've repeated 10 times.
Good point.
Right? So that's the question I'm asking. Where are you in the language? Are you taking advantage of these new features? And it's the same with JavaScript. I would argue it's worse with JavaScript because it's been more fragmented than C# ever was. So I would argue this. The language is less important than the platform. You can learn languages fairly quickly. In fact, there's an advantage to being fresh into a language if you study the platform and look at the current practices around using that platform well with that language. The bigger challenge is bouncing between static and dynamic, jumping between object-oriented and functional. Like, those are very different ways to think. But if you got to handle object-oriented language, you're going to be pretty good irrespective of the syntax that applies.
Good point. Now, that's a good question about how to learn the platform when so many things focus on language. I remember back in 2005 or 6, I read CLR via C# by Jeffrey Richter. They went deep into the bowels of the runtime and garbage collection and everything. Maybe I'm just not up on it. What's the best mechanisms for somebody getting into the platform today to learn it?
I think we still got a non-trivial set of reference apps out of there, like apps you want to look at as the way they've sort of applied using these different features. GitHub has tremendous repositories around a lot of this. So it's not a bad place to simply look at how the modern software is being architected and who's building things with it. And that's the brilliance of the open source wave, is that everybody's source code is visible for you to poke into. I appreciated what Jeff was doing with his book in that era, was convincing C++ programmers that memory managed object orientation wasn't insane. right?
Yeah.
You were trying to talk a very skeptical crowd into it. How many people think about garbage collection today? It's pretty rare, right? We've now sort of lifted up a higher level on the platform, and it doesn't matter to us anymore. Once upon a time, C# only ran in Windows. That's simply not true anymore.
Right. And yeah, and who has discussions of, okay, I'm declaring this variable type. Is that memory going to go on the heap or the stack?
Yeah.
And it was with the latest C#, the non-nullable strings and non-nullable types. Does that actually change some things from the heap to the stack, or is that just...
It does, but you don't need to know.
Well, okay, you don't need to know, but for some reason I want to know.
Yeah. See, that's because you're old, Jeff. That's, we operating systems are literally falling into irrelevance now, right? Where it's just part of the plumbing. What do we really want from an operating system? Reliability.
Yeah. Run my app, please.
Yeah, because I got stuff to do, right? And that's an interesting reality, is thinking what we now perceive as plumbing in development that used to be the stuff we focused on.
Right.
So that more and more we're able to get to terser syntaxes where we're really just talking about the business value we need to code. It used to be a major capability to be able to write multi-threaded code. Like that was a magic power. And if you had that skill, nobody cared what language you were running in or any of those things. It's like, you can make the multi-threaded stuff work. I need you.
That's
Today, you call async on await, and it just happens. And if it runs multi-threaded, you don't even know. All you know now is that your code's not waiting.
Yeah. And it's technically possible to load two app domains in the same process so that you can have two sets of statics, but you should never do that.
Yeah, that doesn't make it a good idea. There's always a rule with good tools, right? If you can't shoot your foot off with it, it's not a good tool.
Right.
So it's got to be powerful enough that you can take your foot out, right?
Okay, so your .NET book, when's it coming out?
I'm pressing hard for the end of the year.
Okay.
And then I'm going to put together a Kickstarter in the fall to pre-sell, and I'm going to build a tour around it too. I think folks who want to hear the stories, like there's the story that I'm writing, but there's also the story of writing it. And one thing about me, if you follow me for any length of time, is I can put on a show.
Oh yeah.
So I think I sort of, I'm not going to be your book author type sitting in a Chapters or an Indigo Books behind a table signing copies. I'm thinking going out for an evening, telling some stories, maybe reading an excerpt, taking questions and having some fun with. We've had more than 20 years since the first ideas around what would become .NET.
Right.
And it's transformed itself. And I think in the process, it's transformed Microsoft. And it's something worth celebrating. The light is shining very brightly right now. And it's great to sort of look back and say, well, how did it get here? What happened along the way? And how dark did it get? Because it got really dark.
It did. And yeah, think about the brains. Just think about Anders Hausberg and the languages that he authored and designed even before C#. And
the only time he ever invented a language from scratch was C#.
Yeah, that's amazing.
Everything else was an existing language that he made great versions of. And Delphi is sort of halfway in between, and nominally Pascal, but a remarkable object-oriented Pascal.
And a great UI
he would
toolkit.
not have made C# if Microsoft couldn't have kept making Java. Microsoft had a very popular Java implementation that Anders was building tooling for. That's what he came to Microsoft to do, was to do tooling for J++.
Yeah.
And then Sun Microsystems sued Microsoft because they weren't following the letter of the license around Java, and so they had to stop. And then there was a question of, what do we do now? And there was actually a competition. There were two different new object-oriented languages being developed internally at Microsoft, one of them led by Anders. And that's the one that was a C object-oriented language, which was later known as Cool, and eventually as C#.
So there was a 1995 book named Microsoft Secrets that kind of chronologued probably the late 70s to 95 era. Your book might be in that vein, kind of chronicling the last 20 years of Microsoft, at least on the development side.
Yeah, I think you're right, because the number of books written about Microsoft sort of ended around the XP time period, which is also the point at which Microsoft and the Department of Justice got into their big tangle that led to the consent decree and Bill actually stepping down as CEO and becoming chief architect. And the company was never the same after that. I don't think anybody's really written about them since then. Culturally, they've dramatically changed. And part of that was taking something that was built for enterprise developers for Windows and turning it into an open source cross-platform product. And the other is, of course, the emergence of the cloud, which has fundamentally changed their business and every business, actually. Right? This is a new state of civilization. And I don't think I'm exaggerating when I say that. Like, our society has evolved into cloud being this concept of utility computing, like water or electricity. It's just a utility you consume on demand. And we're still in the midst of that transformation. It's the huge opportunity space.
Right.
And the fact that Microsoft, unlike many companies, has been part of that transformation is very interesting to me. And I think this story is part and parcel of that.
Well, we will certainly look forward to that book coming out later this fall, and we'll announce it and plug it whenever it does. And
I appreciate that.
I really appreciate.
We're trying. Yeah, we need to reflect a little on what we've done and to celebrate a bit too, because there's some pretty good things here. But there's some learnings too. We've made some mistakes along the way, but it's worth talking about. I'm looking forward to it. I'm looking forward to being done. It's a story I'd love to read, so I guess I have to write it.
You have to finish it.
Yeah,
we'll look forward to that. I really appreciate you coming on the show. This is a great conversation. I'm sure the listeners really enjoyed and learned quite a bit today. Thank you.
My pleasure.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.